Welcome to EasyMathWithDami. Today we'll be looking at the problem on the screen based on the request. So this kind of problem is called improper integral. How do I know it's improper integral? It's because one of the boundary points is infinity. So if both are infinity, it's still the same thing, right? So like negative infinity to infinity, it's the same thing as improper integral. So there's nothing to be scared about. So now the question comes like evaluate this integral. Basically what I need you to determine is that to determine if this integral diverges or converges, and then what it means basically if it diverges, like the integral goes to infinity. So if it goes to infinity, it's diverges, alright? And then if it goes to like a constant value, let's say belonging to R, then we can say this converges, right? That's it. So if I evaluate this integral and I get a particular value, then it converges. If I get something that goes to infinity, it diverges, right? So that's kind of explicit. So now we have to solve this integral. So we'll be applying some techniques of integration that we know, right? To solve that, all I have to do is just rewrite this guy like this. So I say the limit of t as t goes to infinity, or 0 to t. Essentially, what I'm trying to do is just that I'm just trying to I just replace that, right? The limit as t goes to infinity and then t instead of infinity. So if you have negative infinity, it's still the same thing, right? You don't have to get confused with that. So now I just have to apply the normal techniques, and then I solve these, and then I slot in the limits, and whatever happens determine what happens to the integral itself. So to solve this, I have to use a substitution method, which is always called u-substitution, right? So I'd say let u equal 1 plus s cubed, right? So which implies that du equals 3x squared dx, right? So I can decide to just change the interval, or as well I can just leave it like that. I'll evaluate it and then I replace what my u back in the integral, so it doesn't really matter anyhow you want to do it. So this like this, 0 to t, right? This is x squared, and then this should be u, right? Yeah, that should be u, and this is going to be that's gonna be du over 3x squared. Yeah, so this guy cancels this guy, right? So I have my limit as t goes to infinity, let's say 1 over 3, so I could just pull that out here, 1 over 3, right? And then this is 0 to t, 1 over u du. So this is limit as t goes to infinity, just write that, that's gonna be this, right? So that's gonna be u raised to power 1 over 2. So I can just do my normal integration on it, right? That's a plus 1 over plus 1, something like that. So this is gonna be limit as t goes to infinity minus 1 over 2 plus 1 over 1 over 2 minus 1 over 2 plus 1, and the interval stays. So just trying to be explicit with it. So this is 1 over 2 and this is 1 over 2, right? And that's so 1 over 1 over 2 is going to be 2, right? So and then our u, we have to replace it back, and that's going to be 1 plus s cubed, right? 0 over t. So now since we have this, we could just substitute our our infinity back in the expression and see what we get. So this is going to be 2 over 3 1 plus, okay, so let me just put it back as infinity. So limit t goes to infinity, right? 1 plus t cube minus 1 plus 0 cube, right? So that's 2 over 3 limit as t goes to infinity 1 plus t cube minus 1. So now I believe you can actually see what's happening, right? It's pretty obvious that we're just having ordinary t cube here, and this guy goes to infinity when you substitute infinity in it. So clearly our integral, which is this, right? Our integral, which is this, what happens to it? Diverges. The integral diverges, right? So since we have that the integral diverges and that's the answer, how do we know? Because we have infinity. So let's assume we have something like 0 or something 1 or something like that, then we can say that the integral converges. But in this case, it diverges. So, and that's how you solve any problem that looks like this. So kindly ensure, if you like it, ensure that you if you like what I've solved, ensure that you like, subscribe, and then share. So I will see you on the next one. Bye for now.